factoring polynomials using the distributive property. So up until now we've been multiplying with our polynomials, and now we're going to undo that multiplication. So we're going to break down a product into its factors. And we're going to get more and more complicated as we go. We're going to start out pretty simple, but we're going to look at some different methods that we can use for factoring, just like when we're factoring constants. We have some certain patterns that we can follow. Same thing with our polynomials. We'll look for certain patterns as we go along. So we use the distributive property to multiply, but we can also use that distributive property to help us factor also. So when we're multiplying, we looked at taking a monomial in the front here and distributing over each of the terms in a polynomial. So my 3, I'm going to do 3 times a, and I'm going to do the 3 times the b. When I undo that, I'm going to look at each of the terms in my polynomial and see if they have anything in common. So notice that both of these terms in 3a plus 3b have a factor of 3. I can take that out, kind of think of that as an undistributing. I take that out of each term. I take the 3 out. 3a divided by 3 leaves me with a, and 3b divided by 3 gives me b. So I end up with the 3 pulled out in front and the ab as a binomial in my parentheses. And you can always go, you should be able to go back and forth here. I should be able to look at this list of factors and say if I multiply them together, I should come up with this product. Again, if I have all variables here and x in front, I can do x times y and x times z. And I can go the other way. If I look at this binomial, I realize that each of the terms in the binomial has a factor of x. I can undistribute, I can take out, I can factor out that x and put it out in the front here to use as my distributive. And what remains in my parentheses is a binomial y minus z, so the remaining parts of that factor. Same way here, I've got my 6y in the front, 6y times 2z, and I'm going to do 6y times 1. You'll notice the 6y is repeated because I've multiplied it by both of the terms inside that binomial. And then when I multiply them, I get 12xy plus 6y. I can work that backwards to factor it. I can take my 12xy plus 6y, and notice that each of these have a common factor of 6. 12 and 6 both have a common factor of 6, and they also have a y. So I'm going to take the 6y out of both of those. That leaves me with a 2x plus y. I can put those together in my binomial because I distributed the 6y over each of these. So having an idea of what these factors look like before we multiply them is going to really help you factor out the monomial or even a binomial. We'll get to that from a polynomial. All right, so let's see how this works when we put it into action. So we're going to be factoring a bunch of polynomials here. So I'm going to start with a binomial. So when I'm working with a binomial, really I'm just going to look for, does each of these terms have a common factor? So I have 30x plus 48y. So the 30 and the 30 have a common factor of 6. So I can take a 6 out of the 30x, and that leaves me with a 5x. And I can take a 6 out of the 48, and that leaves me with an 8y. So 30x is 6 times 5x when it's broken down. 48y is 6 times 8y when it's broken down, which means that I'm going to do the 6 is getting distributed, so that's out in front. And then what's left in my parentheses here is the 5x plus 8y. Again, you should be able to work backwards and say if I multiply these together, I should get this as my product. And that totally works. 6 times the 5x, 6 times the 8y. All right, let's work with a trinomial here. So I have 30mp squared plus 2m squared p minus 6p. So again, I'm going to look at all three of these terms and I'm looking for a common factor. This should be your first step when you're factoring any polynomial. First, see if there's any common factor that you can take out of all of your terms. Even if there's 7 terms, is there a common factor you can take out of all of them? So here I'm looking and I see that with my constants, my coefficients, I can take out a 2. And with my variables, I can take out an m, I can take out an m, but I can't take an m out of this last term, so that's not going to help. I can take a p squared. I can't take a p squared out of both, but I can just take p to the first power out of both. Oh, and I can do that again here. So I'm going to take a 2p to the first power out of all three of these terms. And what does that leave? Well, if I factor out 2p out from this one, it leaves me with 15mp out of my second term. If I take that out, it leaves me with just the m squared. And if I factor that out of my third term, that leaves me with a negative 3. So I'm left with 2p and then in parentheses, 15mp plus m squared minus 3. So again, finding a common factor amongst all three of them. All right, so we've done binomial, we've done a trinomial. So now we're going to look at terms, polynomials that have 4 terms in them. And how do we do that? So again, first step, always, right out of the gate, check for a common factor. So I've got 6y squared minus 4y plus 15y minus 10. Any common factor here? I can take 2y, 2y. I can't do, they don't all have y, and I can't take 2 out of all of them. So there's no common factor. All right, well, what can we do at that point? When you have 4 terms like this, you can think back to when we were multiplying, and we knew that to get 4 terms, I could do a binomial times a binomial, because I'd mix and match those 4 terms, and I would come up with 4 terms, and then I might be able to simplify. So I have 4 terms, so let's see, can we back this up to a binomial times a binomial? So I'm going to group these. So I'm going to take my first 2 terms and group them, and my last 2 terms and group them, and I want to have a plus sign in the middle. So I'm going to have a plus sign in the middle there. And then I'm going to see if there are common factors in each of those binomials that I've just created. So 6y squared minus 4y, those have a common factor of 2y. So I'm going to pull a 2y out of this set of factors and see what that leaves. That leaves me with a 3y minus 2. All right, now I'm going to work with the second binomial here. 15y minus 2, I'm going to see if that has a common factor, and it does, has a common factor of 5. And when I take 5 out of this second binomial, I'm left with 3y minus 2. So what I want you to notice here is that in the parentheses is the same binomial. So it's exactly the same in those 2 sets of parentheses here, which means that that is one of the binomials from my original multiplication problem. So one of my set of parentheses is going to be 3y minus 2. Now the other binomial is going to come from this other term we have here at the front and this second term that we have here at the front. So these 2 together will be my other binomial. So I've got a binomial times a binomial. So again, those 2 binomials came from this repeated binomial here, and then these loose terms that are in front of those binomials that we factored out, kind of undistributing there. So again, and you could take this and kind of work backwards if we went up the page here. If I took these 2, I would do 2y times 3 minus 2, and I would do 5 times 3y minus 2. There that is. And then I would multiply them to get these 4 terms. So I'm starting with this product. I'm backing it up to these factors to start with. So again, this works for 4 terms. I'm pairing them off, and then I'm making sure there's addition in the middle. So let's try it again with this next one. 4m squared plus 4mp plus 3mp plus 3p squared. Any common factor here? No, I can't take, nope, there's no common factor that I see there. I can't take 2 because I've got the 4s. I can't take 4, I can't take 3, I can't take m, I can't take p. So no common factor. It is 4 terms, however, so I'm going to try to group them into pairs and see if I can back this down to 2 binomials. So I'm going to pair this off. I took the first 2 and paired them. Addition sign in the middle. I'm going to take my second pair and pair those off. Now I'm going to see if there's a common factor here. There is 4m, and that leaves me with m plus p in the middle in my parentheses here. I'm going to see if this second set has a common factor, and it does. It's got 3p, and then that leaves me with m plus p. And again, this is what I want to have happen. This is that goal of setting it up like here when I've got 4, is that in this set of parentheses I have the same binomial written twice. Okay, that's one of my binomials. And the other binomial is these they kind of look like coefficients. They're stuck in the front. I'm multiplying them by those parentheses. So my 4m plus my 3p becomes my other binomial. And again, if you kind of work backwards, thinking we're multiplying here, 4m times m plus 3 and 3p times m plus 3. There's my second piece. So here's my answer. Those are my factors. All right, one more. We're going to do 12a squared plus 3a minus 8a minus 2. So I am going to split these out. First I'm going to look for a common factor, and I don't see one. So now I'm going to split these up. So I've got 12a squared plus 3a plus, don't forget this has to be a plus in the middle here. So I've scooched that negative sign over so it's with the 8a, because that's really a negative 8a. It's not a minus, and then that's a positive 8a there. I'm going to scooch the negative sign over with 8a and minus 2 in my second set of parentheses. All right, I've got 3a that I can take out of my first set here. And again, what I want to have happen is that I replicate this 4a plus 1 over here. So notice when I look at this, the only way to get 4a out of this is to take a negative 2a out of here. So take a negative 2. So take a negative 2 out. That leaves me with 4a. Hopefully I end up with plus 1. And a negative 2 divided by negative 2 leaves me with that plus 1. Okay, so notice that because this doesn't make it go away, negative 2 divided by negative 2 isn't 0. That's got to be a 1 in there, just like 3a divided by 3a is 1. So now that I've got my marker. Got it. All right, so now that I have my binomial twice, now I can put these together. So I can go 4a plus 1 is one of my binomials, and 3a plus the minus 2 plus the negative 2 there, so 3a minus 2 is my other binomial. So we're always going to start off when we're factoring by looking for a common factor. That's our first step right across the board. And then our second step is to look and see what we have. Binomial and trinomials. For right now, we're just looking at common factors. If I have 4 factors, then I can pair them off and see if I can come up with a binomial times a binomial that would have been my original factors.